Kirchhoff's current law, commonly referred to as KCL, is a fundamental law in electronics established by German physicist Gustav Robert Kirchhoff. KCL is one of the foremost central laws, significantly aiding in comprehensive understanding of electronic circuits. It assists and enables easy circuit analysis for both simplistic and complex circuits. Kirchhoff's current law states, the sum of the currents entering a junction must equal the currents leaving the junction. This simply states that the algebraic sum of all the currents flowing in and out of a junction or node are equal to 0. In order for KCL equations to be generated, assumptions for calculations must be adapted. These assumptions include all currents entering the junction having a positive convention, while currents leaving the junction being negative. One example of the application of KCL and these assumptions is demonstrated in the following section of a circuit, where we are asked to calculate the currents I3 and I4. To start, we know from the information provided that I1 equals 2 amps, I2 equals 3 amps, and I5 equals 1 amp. Now we can write the KCL equations to solve for each current. Analysing the circuit around junction A, we can see I1 and I2 are both entering the junction, while I3 is exiting the junction. Therefore, we can conclude that I1 plus I2 minus I3 equals 0. Due to both I1 and I2 entering the junction, these two currents are positive, while I3 is negative as a result of the current leaving the junction. As we are given currents I1 and I2, we can rearrange the formula, placing I3 as the leading value. Therefore, I3 equals I1 plus I2. Subbing in given values, we obtain I3 equals 2 amps plus 3 amps, summing to 5 amps. The same process can be used around junction B, where the formula I3 minus I4 plus I5 equals 0, and can be concluded where I3 is now entering the junction, therefore positive. Rearranging the formula, making I4 the subject, and then subbing in given values using the I3 previously calculated, it is deduced that I4 equals 6 amps. As demonstrated through this example, Kirchhoff's current law significantly enhances circuit analysis